alaikum.
Assalamu alaikum. Good afternoon, girls. Sorry, I was 2 minutes late. Actually, I was with the grade 8 students, so I was having a lesson with them. So to wind up, it took me 2 minutes. How are you all, girls?
Alhamdulillah, miss. How are you doing?
Alhamdulillah, I'm also fine. And you know that this week will be the last class. This week will be the last class before the Eid holidays, isn't it? And definitely,
This week is
the last.
this is the week.
Yeah. This Thursday will be the last class before the Eid holiday. And after the Eid holiday, hopefully it will be the online evaluation and all this. We'll let you know what is
When are we reopening? When are we gonna like rejoin the classes?
31st of May.
31st
Online
May.
classes will resume again. For you, I'm not sure. We'll be informing you what we will be doing about you. Okay. So
Then when
yes. So
It's 31st May, right?
yes, 31st.
Okay.
This Thursday, it will be the last class before the Eid holiday, and then the Eid holiday will start. Okay, guys. Now, tell me, how's everything going on with you? What are you doing?
Well, I'm revising all the topics I don't know and I keep forgetting.
It will not be like that. Don't worry, inshallah. Okay, shall I take the
Revising those topics which I don't I keep
yeah,
forgetting.
that's good. That's good. That's really good. Okay, because you know that as I told you, like especially this general physics, all these topics here will be very different. Especially unit 1, the one you'll be having if you're taking physics in the L11.
Thinking about IG still gives me chills, and teachers ask me to consider myself an A-cells. That would be very deadly to me, to be honest.
No, but you have to do it like this, and this will help you a lot because the same topics you'll be having there. I told you, right? Some addition will be there with this.
Yes, miss.
Now, do you remember what was the last past paper that I actually practiced with? I don't remember. Was it 12, 13, 14, something like that? I'm not sure. Last week.
So we are going to continue with the general physics questions we were doing?
I think so. Because this is, and I think hopefully you don't have any other doubt in any other questions.
Okay, so just take out.
I think we have reached 2013. Is there anyone who remembers what was the last thing that we did in
we were doing 2014.
13 or 14?
Well, miss, I'll check and I'll tell you.
Sure. Okay. By the time I can do that and then. Okay, I can see. Oh, Sarah is here today. Sarah, how are you?
how are you?
Alhamdulillah, I'm fine. Nihat, I'm asking Sarah because she's for the first time I can see her in my class. Sarah, are you there? How are you?
First time in forever.
Excuse me, miss?
Yes, dear.
I've got it. We're going to start from 32, October, November 12, question number 2.
Okay. Yes, Sarah, good evening. How are you? Okay. Adina, Ishina, Rahma. Okay, I'll take it after this. Okay, so it was 32 October, November 12, right? 32 October, November 12, question number.
It's some plane on the second question.
32 October, November 12.
Question number 2, miss. Yeah, October, November 32, 12, question number 2.
Oh, yes. Yes, I remember. That day the water splashing roller coaster, I would say. Yeah. That this is also, a parallel journey. Okay, let's do this. Okay, this is here. That is an aeroplane. Okay, that is flying at a constant speed. Okay, in a circular horizontal path. Okay, the center of the circle is to the left of the force. Definitely. This is here, but you have to draw there and then you have to explain. So if you just look at the motion or look at the diagram the way they did, it gives us an idea that where will be the center. Is it
obviously
in the left side or right side?
On the left, right?
It is in the left side. So definitely you'll be drawing an arrow perpendicular perpendicular to the what should I say, to the vertical, perpendicular to the vertical, or a horizontal line, straight a horizontal line that will
Miss,
show
could you
us.
please send the picture? I'm actually not understanding the direction. Like, I know it's in the left, but then how?
Listen, just from the center, that circle thing was there with four small squares, right? That is the face of the
Yeah.
front of the
Yes.
aeroplane. From there, you draw a horizontal line straight to the left side, and arrow on the top. That's it. Okay. Then they say here that you have to extend. Okay, fine. We can say that as okay, it is centripetal force, isn't it? So we can say that the centripetal force is acting towards the center of the circular path to change the direction and accelerate.
Centripetal force is
acting towards the center of the circular path. Centripetal force acting towards the center of the circular path to change the direction and accelerate.
Circular path and change the direction.
And accelerate. Because we know that when an object is moving in a circular path, it will always have a constant speed. So if it is in a constant speed, it has to change the direction to get velocity and accelerate. So that's it.
So center of circular path to change the direction and accelerate.
Exactly. Okay. So now look at the diagram then. The weight of the airliner they give, and there is an aerodynamic weight, they say. So weight, we know that it will be working vertically downwards, isn't it? Fine. So we can say that is the, okay. If you remember, the way we are drawing, that is north, south. So it is coming downwards. So W will be working downwards. And then what happens there? There is an aerodynamic force of this amount acting at 30 degrees to the left of the vertical. Okay, fine. So if I draw a straight line, right? Roughly, if I explain to you, if you draw a straight line downwards, you give an arrow and write down W. And then from the middle, you are going to draw a line, and roughly we say that that is 30 degrees from the vertical. So if it is 30 degrees from the vertical, that is the aerodynamics. Give an arrow on that. And then what will be the angle between this aerodynamic lift and the weight? How can we find it out, say? As I say, weight force is working downwards. Anyone else can also give me the answer here. Listen to me. Weight force is working downwards. And they say there's another aerodynamic lift which is actually flowing, making 30 degrees to the vertical. So W is actually working vertically downwards. So
90 minus 30.
Not 90.
60.
Right? No, not 90.
Is it 60?
No, it will be 180 minus 30.
180 minus 30.
Exactly. Okay. Then what is the angle coming out then? 150 degrees. So the angle between these two forces is becoming 150 degrees. One is the weight force, another one is the aerodynamic lift. 150 degrees. Okay, fine. They say by drawing a scale diagram. So this is also you're going to do later and show it to you. A scale diagram, or otherwise they say, we'll go with the scale diagram. Show that the resultant of these two forces is in the same direction as in the resultant force you drew on A. Okay, fine. So what will we do? We'll be drawing a parallelogram. You know that. So here they did not give us any scale or nothing. So we can choose a scale. So shall I give it to you as homework, Anika? You try and send it to me.
Okay, miss.
Okay, fine. So then let's go for courtesy of the question. So here they say the speed is constant, the one I was explaining initially to you. The speed is constant as the airliner flies in this circular path. Okay, everybody knows that. Can you explain what is happening to the velocity? So we say that an object which is moving in a circular path is going to have always a constant speed. But in its circular path, if in every point, it is going to change its direction. So when the direction is changing, definitely the velocity is changing. Right? So you have to mention that one only, right? It is the speed is constant, but the direction changes continuously, so velocity changes. Simple. Did you understand?
Yes, miss.
Fine. Okay, I think question number 3 is wrong. Okay, those are all thermal physics questions. Let's leave it now and let's go to 31 May June 30. Now you can go to 31 May June 30 that way. 31 May June
31 May June.
13, question number 1 onwards will be. Okay. You just take it out by the time. Yes, okay. I can see that my share is also here. Okay, let me take out the attendance. Alia, Miheen, Amina is not here, right? Today? Zareen, I think she is here. Yes, Zareen is here.
So are you taking the attendance right now?
Zareen
Okay.
is here. Nureen is also here. And then Alpha, please, Alpha here, Mansha.
Miss, can you speak a little louder?
Yeah, sure, dear. Why not? Okay. So I was checking your attendance here, that's why. Okay, I can see today Nuzaima and Sanjida is not here. Amina Islam Fatima, these 4 students are not here. Okay, guys, did you read that question 31, May June 30, question number 1? Got it?
Yes, miss.
Okay, fine. But I just want to ask you, is there anyone from your class collected the A-level books, like Unit 1 book? Of course, Unit 1, 2, and 3 together, it is a single book. Is there anyone collected that book for you for physics? Did anybody? Because
Miss.
No, Miss.
not yet, okay. Now, those who are planning to take physics, you can just ask someone from the senior grades, especially the grade 12s, because they are the outgoing students. So they have already finished Unit 1, 2, 3, and all. 1, 2 is together one book, and we are following the Pearson book. So those who are planning to take
Miss,
physics,
whenever we ask us questions like that, they'll be like, oh my God, IGS is nothing in front of ASL. It's very hard. Whenever we go to them, they just depress us instead of encouraging. So thank you, Miss. It's better to ask you.
no, it's not like that. I told you, right? Okay, think about something.
They're themselves very
it can
stressed.
be,
How can they help
no,
us?
no, it's not like that. Look, something can be like if you ask the grade 4 or 5 or grade 8 students also, they'll feel disease is too hard for them, isn't it?
Exactly.
So,
How can that be helpful to us? Because they're going to anyway depress us saying that.
No, it's not like that. But you remember one more thing, that it's not that everybody will feel the same. Who knows, it might be easy for you. So,
Yes,
until
miss.
or unless you give it a try, you cannot say anything about it. Okay, fine. But I'm asking you that if you are planning to take, you can just go to the book, have a look at it, then you'll see it's nothing. But as I told you, the time is short, because if you start September, October, November, December, then January will be active. So it's kind of really fast. IGCC, you studied 3 years, and of course you didn't write, so you don't have the experience. But those who wrote also, like after 3 years of preparation, they went for the exam hall, right? And here within 3 months you have to write down and you have to get ready for that. That is the part where most of the students make mistakes. They think like IGCC, okay, fine. I stepped into grade 11, let me relax, look around, then I'll study. But we don't have time for that. Okay, inshallah, the senior teachers will also have class with you so that you will understand. They will make you understand. And if you are serious enough, inshallah, you will. There's nothing to worry about. I told you many times that the students from our school are getting full mark in physics, full mark in biology, full mark in math. And why will you not be getting? Inshallah, you will. Okay, guys. So let's take 31, May June 30. Question number 1, define density. Okay, Alia, could you tell me, do you remember the definition of density or the formula? Alia, could you give me the definition or the formula of density? Do you remember? The definition of density.
Yes, Miss.
The definition of density or the formula. Both you can.
The mass per unit volume.
Okay, so mass by volume we are going to say. So it is mass per unit.
Miss, mass by volume.
Yes, rho equals to m by v. Fine. Okay. After that, we have a question. If you are having the particle in front of you, then it will be easy for you to look at. The density of aluminium is 2.70 gram per centimeter cube. The thickness of a rectangular sheet of aluminium foil varies but is much less than 1 millimeter. Okay, the student wishes to find the average thickness. She obtains the following measurement. She got the mass, the length, and the width. Okay, calculate the student's value for the volume of the sheet. Okay, fine. We know the formula rho equals to m by v. So from there, if I derive, I can easily get volume equals to m by v. Okay, I want someone to go for the calculation and check. Rho equals to m by v, then v equals to m by v. So your mass is 60.7 and rho is 2.7. Okay, Anika, are you following?
Yes, miss.
Yes.
So
Please take the
60.7,
divided by 2.7.
2.7.
Yes.
Yes, miss. It's 22.5
22.5, okay.
centimeter cube.
Yes, definitely. It's volume, so it's centimeter. Done. Okay. Then the
Correct.
average.
It's correct, right, miss? I couldn't hear you.
Yeah, it is correct. 22.48 gram per centimeter cube. It is correct. Okay. Now check number 2, the average thickness of the sheet. Fine. So we know the thickness comes from the volume. So volume equals to
Go for cuboid, volume of cuboid, LBH,
yes.
right?
Yes. So length and width and height. So you can consider you are finding out the height. So H equals to V by and into W. That's the calculation. Volume you found right now 22.5 divided by, we have here 50. That is the length, and the width is 30.
So we're finding out height over here.
Exactly. That would represent the thickness. 22.48 divided by 50 multiplied by 30. It might come out as a small number because we have the denominator much larger than the numerator. And also checking 0.015 unit. 0.015. Did you get? 0.015. I got. And of course it is centimeter because thickness. Got it? 0.015.
0.015. Yes.
Okay, fine. Then.
Centimeter, right?
Yes, it is. Another student provided with a means of cutting the sheet decides to find its average thickness using a single measuring instrument. Assume the surface of the sheet are perfectly smooth. Fine.
Micrometer.
Yes, micrometer or screw gauge.
Screw gauge.
Yes, screw gauge. Describe the procedure. Okay, this is in our copybook, remember? We learned there that we are going to place the.
Miss, I actually cannot hear you properly. You're too low. I mean.
I don't know, but that's pretty loud. Okay, fine. Now, check. Is it clear? Okay.
Miss, I think it's something with the room you're sitting in, because sometimes I hear you like better, and sometimes it gets too low.
I don't know. Yeah,
Does everybody else feel that, or it's just me?
I don't know. What about the rest of the girls? Could you hear me? Loud and clear?
Yes, miss.
Yeah, they can
Yes,
hear.
we can hear you.
It's
Okay,
Yes,
then.
I would say this, that your voice is much lower than others, all the time.
Yeah.
Okay, fine. Okay, fine. I'll try to speak out a bit loudly. No problem. Okay, so this thickness, how to measure the average thickness of the sheet, that one you can do, right? In our copybook.
Yeah.
Fine. So let's go
That's
to,
micrometers.
yeah, that is the most easy question, and it came out 2 times as well. So let's go to
Yes.
this question number 2. 31, May 13, question number 2. Okay. Underline the vectors in the following list of quantities. Okay. They gave us density, energy, force, mass, velocity, volume. Okay. Which one?
Velocity,
Mm-hmm.
and then
Okay.
force.
Of course. Force
Mass.
and then, no. Mass is
Oh,
not
mass is not
space.
weight is vector. I'm sorry. Weight is vector.
Exactly.
And weight is not
So,
over here.
force
Is
and
this
velocity. Just 2. Force and velocity. These are the 2
Yes.
which are good. Okay. Now check part B of the question. A small metal ball is projected into the air with a velocity of 40 meters per second vertically upwards. Okay. Let me remind you, this graph will get a level as well. Same thing we have. The graph in this figure shows how the velocity changes with time until the ball reaches its maximum height. Okay, we know that we are going to throw it with a certain velocity, Means the diagram, the way they gave to us, we can understand. We are showing it with 40 meter per second. And every 10 seconds, we know that it's going to lose the velocity by 10 meter per second because K is the acceleration due to gravity, roughly. Okay. So they're asking, use the graph to find the time at which the ball reaches its maximum height. You remember, when the object goes to a certain height, I told you that particular point, the velocity will become zero. From there, it will start falling downwards with the acceleration due to gravity. So if you just look at the diagram, which point is actually at zero? Could you tell me? Which point of time the object is at zero velocity?
So maximum height can be distance as well.
We are not discussing about the one. That will come later. But first, the time we said, not height. The time at which the ball reaches its maximum height. I said when a ball goes to its maximum height, the velocity becomes zero.
Yes.
So on the graph, check at which time the velocity of this graph line is zero.
It's 4 seconds.
Not 4 there, it is 4.1. Did you notice that?
Oh yes. Sorry, I didn't notice that. It's 4.1.
It is 4.1 seconds. That's nice. You don't need to do a calculation. From the graph, you can calculate. Okay.
4.1 seconds.
Exactly. Now, definitely we can understand it was deceleration because initially the speed was 40, now it became 0. So there are.
So it's area under graph.
Exactly. No. Deceleration is slope of the graph or gradient of the graph. That is
So y2 minus y1 by x2 minus x1.
Exactly. So if you just look at it, initially x1 is 0 and y1 is 40. And finally, y2 is 0 and x2 is 4.1. So it will be on the top 0 minus 40 divided by 4.1 minus 0.
4.1 minus 0.
Exactly. Check the answer will come out in terms of negative. That will be the answer that is deceleration. Because for deceleration, we don't have any separate formula.
Miss, it's minus 9.75 or 76.
Okay, so we can make it minus 9.8 meter per second square.
Minus 9.8 meter per second squared.
But do remember when we're writing deceleration, the word final answer, it will be only 9.8 meter per second square. As deceleration word is there, you will not use the minus sign.
Okay. Oh, we'll not use the minus.
No. Final answer. In deceleration, when it is written, you know. Now, take the next part. The maximum height reached by the ball. Okay, it is area under the graph. So it looks like a triangle.
Okay, height is area under the graph.
So half into base into height because it is a triangle.
So half BH.
So half into base is 4.1, that is the time, and base is 4.
Miss, is it 82?
Yes, it is.
Meter.
Okay. Now, part C. On the figure 2.1, add a line to the graph to show how the velocity of the ball changes after it reaches its maximum height. Your line should extend to time 6.6. Okay, now listen. As we know that when we are throwing an object, it goes up, it becomes 0, then it starts falling down in the same time. So we have to just extend the straight line till the end of the grid.
So it's just like a straight horizontal line.
You can say is you will extend the line until it touches the 6 means the grid, end of the grid line. Just the straight line. We will extend the line until it touches the grid. End of the grid.
Like a horizontal line, right?
Not horizontal. Just extend the line until it touches the grid. That's it. Extend the line.
Okay.
So the obviously it will go to the negative side because it is already touching the middle line.
Yes, yes.
Yes. Now, if it is done, we can go to question number 3.
Wow.
Okay, but I want to ask you, I think that you also asked you, I think most of you will be staying for the A-level in our school, isn't it? Yes. What is your plan? Especially the science students, because you are less in number. Today you are in year 12, right? So if I add You are 11 students today. So if I add Rizalma, 12 and Sanjita 30, the other two is commerce students. So 13 students will be pure science students. So among you,
Yes.
all of you will be continuing here, right? For today.
Yes, yes.
Yes, yes.
Inshallah.
Yes, miss, taking the science subjects.
Inshallah. But I think Nuri told me that day he must go to the commerce stream, right, Nuri? That's what you said, but isn't it?
Yes, miss.
Okay, fine. Then it will become 12. No problem. Okay, because I am considering Amina and Fatima, they might be there. Definitely, they have all the commerce subjects they're taking now. Okay. Now, girls, let's go to this question number 3. Shows the descent of a skydiver from a stationary balloon. Okay. If you look at the diagram, the diver is coming out and we open the parachute and is falling down, and there is a certain distance they gave us, 2000 meters, he jumped off, and 500 meters, he opened the parachute. So they're asking the total mass of the skydiver and his equipment is also given. Calculate for the skydiver the loss of gravitational potential energy in the fall from 2000 to 500. Okay, fine. So we know the formula that EP equals to mgh, isn't it? Okay, so the mass is 92 into g is 10, and the distance will become 2000 minus 500 because they're asking to find out in between these two. So 2000 minus 500.
1500.
So 92 multiplied by 10 multiplied by 1500. Check the answer.
Miss, it's 138 followed by 4 zeros.
Okay, so we can make it 1.38.
1.38 into 10 to the power 5.
No, 6.
6, yes, sorry.
6 joule. Definitely.
Joules.
Yes. Number 2, they say the kinetic energy of the height at that height, sorry, at the height is
mv
500.
square.
Okay.
So half into mass
There is
92.
And if you go
Velocity
up, it is written there 52 meter per
52.
second. Yes, 52 square.
square.
Yes.
So that gives me 92 into.
Take the calculation.
Yes, it's 1,2,4,3,8,4.
So you can just, yeah, fine. You can keep it or you can just go to the standard one.
4,3,8,4 joules. Done.
Now come to the other part of the question, number 2, that is A2. The kinetic energy at 500 meter is not equal to the loss of gravitational potential energy. Explain why they are different. Okay. Means we calculated in part 1, 1.38 into 10 to the power 6. Now we put 1.24 into 10 to the power 5. So they're asking why it is different. It was supposed to be the same because we all the time say that whatever the
So some energy is lost or converted.
Okay. Say, because air resistance is there, right? So we have to, the person has to work against the air resistance. So some work has to be done against the air resistance, and some energy is dissipated.
The person has to
work
overcome the air resistance.
Resistance, yes. So to overcome the air resistance, work needs to be done, and some energy is also dissipated as heat. Because whenever there is a friction, there will be a heat energy.
So work has to be done. So some energy is dissipated.
Yes, it's dissipated as heat energy. As heat energy. Because whenever any object is having a friction with the air molecules, it will produce certain amount of heat energy.
Miss, I didn't hear the last few words after dissipated.
As heat energy.
Okay.
Now come to the next part. Say what happens to the air resistance acting on the skydiver during the fall from 2000 meter to 500 meter. Okay, we know that yes, it will be increasing because he just came out. Eventually, according to the time, he will have more friction, so it increases. Correct.
So do I write just increases?
Yeah, fine, no problem. Okay. Then they say the value of the air resistance during the fall from 400 meter means after the parachute. 400 meters to the ground. Okay, so definitely that is the part it is going to balance. Means air resistance is going to be balanced with the weight of the particular person and the parachute as well. And that will be nothing but W equals to mg. So they gave us the mass is 92 multiplied by 10. So we write out air resistance equals to W equals to mg. Because that time it is going to fall with the constant velocity.
Hmm.
So
So
AR
92 into
10.
92 into 10.
Mm-hmm.
It's 920.
920 Newton. 920 Newton.
Newton.
Okay. Now, I think we can go to 32 into 30. Yes. Question number 1.
Fishes.
Yes. That is the fish tank. Okay. And the aquarium, they give us that one. Okay. A large tank in a marine visitor attraction. We have the viewing panel, the tank, water, and behind the tank is
Very few fish compared to a large tank.
Okay. The tank is 51 meter long and 20 meter wide. The seawater in the tank is 11 meter deep and has a density. Okay. Calculate
We
the
can
mass
go
of
for
the
H rho G.
Mm,
No, wait, we can't. It asks mass. Just a minute, please.
yeah, it is mass of the water they ask. So first we'll
Yes,
find
yes.
out the volume. Okay. First
Yeah.
we'll find out the volume and then rho equals to m by v. So volume equals to L.
So
LW.
rho. Yeah, of course.
First find out the volume. LWH. Length is the height. Multiply with the volume. And again, rho equals to m by v, m equals to rho.
So rho into volume,
Mm-hmm.
and here volume. Okay, very easy. So 1030 multiplied by 11 to 20.
We got the volume as 61 multiplied by 20 multiplied by
Yes, miss. 03.
that's it. Altogether, what comes up?
Miss, is it 11556600?
Okay, no problem. So you can write it 1.15 into 10 to the power 7, 10 to the power 7 kg. 1.15 into 10 to the power 7 kg.
Okay.
Okay, done. Then they are saying that the part B of the question, the pressure at point M. Okay, they gave us a point M in the middle, halfway down. Okay, this is halfway. Fine. Down the large green panel is 60 kilopascal, more than the atmospheric pressure. Fine. Calculate the depth of M below the surface of water. So it is H you have to find out. We know that the pressure equals to H rho G. So from the
Yes.
H we are finding out, so H equals to P divided by rho G. Okay, so pressure, this is 60 kilopascal, convert that one to pascal, 60 into 1000, divided by rho is 1030
So
multiplied
it's 60,000.
by, divided by 1030 multiplied by 10, because G is 10. Next, what comes up?
Well, 6,000. Miss, it's 5.8.
Okay, 5.8 meter. It is. Yeah,
Yes.
check number C. The viewing panel is 32.8 meter wide and 8.3 meter high. Calculate the outward force of the water on the panel. Assume that the pressure at M is the average pressure of the whole tank. Okay, so we'll be going for the solid formula. P equals to F by A, F equals to PA, because they're asking for the force. P equals to F by A, F equals to PA.
So
The pressure
area, we
was
just multiply those above,
exactly, and pressure is
and pressure is given.
60,000. 60 kilopascal means 60,000.
So 60,000 into 0.3 compared to 2.8. So miss, it's 16334400. So 1.63 into 10 to the power 7.
1.60 into 10 to the power 7 Newton. Yes, right. So, question number 2, I think we can do now. the figure 2.1 shows the expansion load graph for a spring. Okay, point P is the limit of proportionality. Name the law
Hooke's
obeyed.
law.
Hooke's law. Right.
Hooke's law.
Okay, and describe two features of the graph which shows that the law is obeyed. What is the two
It
features?
has a limit of proportionality.
No, you have to say about the graph.
Okay. Okay. How do I say it?
First of all, remember, whenever two quantities are directly proportional, the graph line will be a straight line. Second point will be to the origin. Straight
Graph
line.
line is a straight line.
Yes. Straight line and to the origin. These are the two features of the graph.
Miss, I couldn't hear the second point.
To the origin. To the origin.
Okay.
Straight line to the origin.
Done.
No. Even we can say straight line with constant gradient. That also we can say.
With constant?
Gradient. Because also, if you calculate, the gradient will come out the same. And of course, it has to be to the origin. So now they say on the figure, sketch a possible continuation of the graph when the string is loaded beyond the limit of proportion. Okay.
It's beyond. I mean, it's kind of curved.
It will be curved towards the y-axis. Okay, because extension is there, it has to be curved towards the y-axis. But if the extension was placed in the x-axis, then it will curve downwards. Now it will go curve upwards. So
Next variant.
Yes, you can go to 31 October November 13. 31 October November 13, question number 1.
Define Hooke's law.
Yes, the same pattern of questions in here. Okay. Okay, you can write down that one. The expansion is directly proportional to the load applied within the elastic limit. Definitely, you can mention it. The expansion is directly proportional to the load applied within the elastic limit. Okay, but as I told you before, that this
Yes, through the origin and the line goes straight with a constant gradient.
Yes. It is actually already there, a straight line, but they are asking, yes, that is fine, that
We just did it now.
exactly. So now after that, they say calculate K, the force per unit extension of the string. Okay.
So F
now
equals KE,
yes. Then
K equals F by E.
okay. And then from the graph, just take one of the value. You can go for 20. If you take 20 in the x-axis, y-axis becomes 50. Okay, but you remember, 20 is given in milliliters. So you have to multiply by 10 to the power minus 3 to convert to liter, because Newton goes to the SI unit. So it will be 50 divided by 20 multiplied by 10 to the power minus 3. Okay, first answer coming in.
20 multiplied by
10 to the power minus 3. Because we are dividing
to the
it
power
by
minus 2.
1000. 3. We are
Or I
dividing
can just
by,
directly write 1000.
then you have to divide if you write 1000. And same 10 to the power minus 3 means 1 by 1000.
So first 50 by 20 and then multiplied by 1000.
But multiplied will be, yes, you can say that. On the other way,
It's 2500.
okay, fine. Newton per meter. Newton per meter.
2500?
Newton per meter.
Yes.
Now, check part 3 of the question. The limit of proportionality of the string is reached at an extension of 50 millimeters. Okay, the one we drew already. Continue the graph to suggest, okay, how the value will be in 125 meters. Okay, fine. So 125 meters. Where the stretching force is increased to 125 meters. Okay, fine. So you are going to just draw a 125 meters. So you will be drawing a line.
Miss, I cannot hear you again.
Okay, I'll tell you. Listen to me. They say here you are going to increase the value above 125 meters. So you will increase it. Think about this line will be curved and it will reach to 150 as a curve. 150.
So it will curve upwards, right?
Yes, definitely. No. It will curve downwards and it will touch the point of 150. When it is 80, means 80 millimeter, it will go to 150 and stop because they said above 125. So I just went to 150, just like that. Actually, the way they gave, you cannot go above it. It will definitely come to 150 as a curve.
So it's a curve where it's where y is 150 and x is 80.
Exactly.
Okay.
That. Now, number 450, let's do that. Another string has a smaller value. Okay, fine. So it will be a straight line just below 8 till 80, a straight line below it. Because we are applying, which is having a value which is okay, possible variation of f and x for this string. Okay, which is having a smaller value of definitely. So it will be a line below this particular graph line, and it will go
A straight line.
Yes, straight line till 80. Means all through it will be a straight line.
So it will not have any curve or something.
No, it will not have.
Okay.
Okay, thank you. So I think we can end our class today. And as I told you in the beginning of my class, that this week will be our last class. So day after tomorrow, in the last class, we can just have some discussion. Okay, guys? I hope all of you will be present there because obviously at this moment I'll be not teaching you in grade 11. So I want to have my last class with you. After the holiday, it will be something else. So it will not be a regular class anymore. Isn't it? Inshallah. Okay, Allah Hafiz, guys.
Allah Hafiz, miss. Have a great day. I'll send you the answer to the.
Inshallah, I'll have a look.
Thank you, miss.
Assalamu alaikum.
Wa alaikum assalam, miss.
Thank you.